Welcome to the channel Maths for Graduates. Today we will see a proof of a theorem, and the theorem is the countable union of countable sets is countable. Okay. Or we can say that if we have countable sets, suppose A1, A2, A3 and so on, AI and so on, these are countable number of countable sets. These sets are countable. Then their union, that means I running from 1 to infinity, AI's, this union is also countable. Okay. Now let's prove. Suppose this set A1 has elements A11, A12, A13, A1I and so on. Okay. And suppose A2 has elements A21, A22, A23 and so on. And likewise, suppose the ith set AI has elements AI1, AI2, AI3 and so on, AII and so on. Okay. So these are the elements of sets. Okay. Now from this pattern we can say that the Aij is jth element of set AI. Okay. Alright. Now let's develop a technique, and with the help of that technique we can count the elements of the union of sets. Okay. So elements are A11, A12, A13, A14 and so on. A21, A22, A23, A24 and so on. A31, A32, A33, A34 and so on. Elements of fourth set is A41, A42, A43, A44 and so on. Okay. Now the sum of the suffix is 2 here. You can see that 1 plus 1 is 2. So sum of suffix is 2 and number of elements with sum suffix 2 is only 1. Okay. Now for these two elements, sum of suffix is 3. You can see that 2 plus 1 is 3 and 1 plus 2 is 3. Okay. And for the sum 3 we have 2 elements only. Okay. And here for these elements sum of suffix is 4. You can see that 3 plus 1 is 4, 2 plus 2 is 4 and 1 plus 3 is 4. So sum of suffix is 4 here, and there are 3 elements with sum 4. Okay. Similarly for these elements sum is 5 and number of elements with sum 5 is 4. Okay. Now we can say that if n is the sum of suffix, then there will be n minus 1 elements. Okay. So you can see that for every sum suffix we can find number of elements. So here we can get the idea that we can count the elements. Okay. Now but let's what we do, we define a mapping from the U set of union to the natural number set, and we'll show that that mapping is 1 1 and on to. Okay. So let's define a mapping. Mapping is from set of union I is running from 1 to infinity AI to set of natural number. Okay. And the mapping is defined as that Aij this equals to I plus j minus 2 and I plus j minus 1 over 2 plus j. Okay. So from this mapping f of A11 will be, here I is 1, j is 1, when you substitute the value we get 1. Okay. Then f of A21, here I is 2, j is 1, on substituting we get 2. Similarly, f of A12 will be 3, f of A31 will be 4, and f of A22 will be 5, and f of A13 is 6. Okay, you can see that every element of union set is mapping to natural number. Okay, and you can easily show that this mapping f is 1 1 and on 2. Okay, so when this mapping f is 1 on 2, we can say that the union set is countable. Okay, and this is what we had to prove. So this completes the proof. Now this video ends here, and I have a quick announcement to make. Those students who are preparing for exams like CSR NET, GATE and other MSc entrance examination can buy our real analysis handwritten notes for a very reasonable price for only ₹80. So if you are interested, you can contact us through this WhatsApp number. Thank you. Thanks for watching.